Let's begin by opening our touch panel file and adding that pop-up page. Within the Netlink Studio workspace, double-click the file to automatically open it in TPD5. Since you have already done this several times by now, I'm going to just quickly cover what I did. First, I created a new pop-up page called Audio Router. On this pop-up, I created a 2x2 routing matrix. The state of the button will simply indicate that if the route is made or not via its on-off state. In order for this to make sense to the user, I labeled my matrix the same way it was done inside the processing object in the Blue 50. The rows will indicate the output numbers and the columns will indicate the source or input numbers. Then I set the programming properties of our 4 buttons. I used port 9 since it was the next available port number. And I assigned channel codes 101 through 104, left to right, top to bottom. I then made sure we had a button called Audio Router in our source select bar. And I set the page flip properties to pop up our new Audio Router page. That's it. I'll save and close the panel file so we can get into writing the code. Once again, it is critical you don't confuse the code file you're working in. Shut down all the code windows you have open and open up the P1 exercise source code file. Obviously, before we can start typing, we need to know a few things about the device we are controlling. We created a document of Blue 50 commands that's included in your course resource materials. Let's import this into the other folder of our workspace for quick and easy access. Open up this document. Here we have all the information we need to control and monitor our matrix router processing object, including serial communication parameters and the actual strings used for control and monitoring. Keep in mind, this is a document that we created specifically for this exercise. These are in fact the actual strings of the Blue 50 that we generated using the BSS Audio Architect software. Let's begin writing our code. As always, we start with the Define Device section. So just as with any programming assignment, you need to know what devices are required. We need to define the touch panel port for our Audio Router page and the serial port we'll use to communicate with the Blue 50. I'll define a new device called DVBSS_Blue50 and use the gets operator to set it to 5001:4:0. And I'll call the touch panel DVTP_Audio Router and set it to 10001:9:0. The exercise then asks us to create an array of touch panel audio router buttons. I'll scroll down to the Define Variable section and I'll name this array nRouterButtons. By this point, you have a thorough enough understanding of persistent modifiers and data types that I'm not going to spell out why I chose what I did for those parameters of my variable definitions. If you are unsure of any of this, please stop here and refer back to the variables tutorial. Now, just assign the router button numbers to the array, 101, 102, 103, and 104. Next up, we need to create a two-dimensional array to store the router commands. I'll name this array sRouteCommands. How big should we make this array? Well, if we look back at our Blue 50 commands document, all of the commands are 18 characters and there are 4 route commands. So I'll set the size of my array to 4 and 18. I prefer to go in order and load the appropriate values into the array right after creating it. So I will now go down to the Define Start section and load the values into the array. To save a ton of typing and minimize the opportunity of creating an error, I'll just copy and paste the values from the Blue 50 document right into the Define Start. Then just prefix each one with the name and the index of the array. Now, we just repeat the process for the unroute commands. Let's call this one S_unroute commands. And once again, this will be a 4 by 18 array of commands. Back to the define start and copy paste the unroute commands. And repeat this process once more for the subscribe commands. I'll call this array S_subscribe commands. After we copy those commands in, we're finished creating and initializing all of our arrays. In addition to creating the arrays of commands, the exercise requirements also said to send the subscribe commands to the DSP as soon as it comes online. Let's jump down to the define event section and add the data event for the DSP. Once again, I'll build this event right before our timeline event, so we can keep the timeline on the bottom. Before we can send any strings to the DSP, we need to set up the communication parameters. If we refer back to the Blue 50 document, we see this device has a default baud rate of 115/200, 8 data bits, 1 stop bit, and no parity. In the online handler, place these settings into the send command for the Blue 50. Also, it's a good practice that when you are doing RS-232 control through a port that also supports RS-485, that you explicitly turn off 485 with the RS-485 disable. Just to remind you once again, you can find this send command in AMX PI2 if you look under the serial port section of whatever Netlinks controller you're using. Now that the port is configured, we can send the subscribe commands to our DSP. We're sending these to the Blue 50 using the send string keyword. The device we are sending to is obviously the DV-BSS Blue 50. Now I'll open up a set of double quotes and I'll put the name of my array in here that has the subscribe commands. S_subscribe commands. Then I'll open up a set of brackets and I'll need to tell it which one of the subscribe commands I wish to send. Well, let's start with the first one. Put a 1 in here. All I need to do now is copy and paste this send string 3 more times. Once I do, change the index of the array to 2, 3, and 4. Don't forget to close the double quotes and add a semicolon after each one. This is a rather involved exercise. Let's take a break here. In part 2 of this tutorial, we'll finish up our data event and build the button events as well.